to them whenever I show you the examples. So an irrational number is a number that cannot be written as a quotient of two integers, meaning it cannot be written as a fraction. Okay. Now a real number is any number that is irrational or rational. So everything that we talk about today is considered a real number. Now when we talked about the other day, when we talked about square roots, we were talking about some imaginary numbers. Even though we didn't do any problems that had imaginary numbers, an imaginary number would be the square root of a negative number. And so you'll talk more about that. I don't know if it's algebra 1 or algebra 2.
I think it's something, it's had, in a couple of years, in my first class, but like, most of my brother's doing them right now with
And it's for sure not
and
in,
he's in college now.
right, it's for sure not in this, and it's not in pre-algebra either. So how do you know whether a number is, okay, so they're all real numbers what we're talking about today. So how do you know whether it's rational or irrational? So obviously if the definition of an irrational number, it cannot be written 0.633. That's the original. So now I can cross this one off because I know that's number 1. Now I'm going to go back to the next two that I was comparing. The next two I was comparing was right here. So the 6 and the 6 were the same, the 3 and the 3 were the same, and then when I got to the third digit, I got 6 and then 3. So which number is the next smallest? So here would be my next one. And I always write it like the original. Now I'm done with this one. So now I need to compare these two, which if I'm looking here, I've got 6 and 6, 3 and 3, and then I've got 6 and 6 again, right? So that doesn't tell me anything. Now the next one here is 3, and what's the next one here? 6. So here's my third, and here's my fourth. So write the original, which would be 0.6. Both of these are repeating, and then the last one would be. So I don't need to write them again. So that's just making sure you're comparing one place value spot at a time. Any questions on that? All right,
Well,
last.
wait,
Yes.
like I said, like, how many zeros you have, like,
It just needs, just until you get to when they're different. It doesn't matter. I mean, just until you see that, oh, this one is different than this digit. And then you can stop. All right, last example, using an irrational number. It says stopping distance. I think this is actually on the driver license test. The equation S equals the square root of 27 times B gives the minimum distance that it takes a car to stop on dry pavement after applying the brakes. In the equation, D represents the stopping distance in feet of a car that is traveling at S miles an hour. So obviously, the faster the car is going, the longer it takes for the car to stop. A car stopping distance is 138 feet. So how fast was the car traveling? So all we have to do is replace D, which means distance, with feet. Okay, and then you'll be able to tell how fast that car was going. Okay, they use this at wrecks all the time because they can measure the distance of the skid marks to tell how long it took that person to stop, and then they translate that into how fast they were going by using this equation. And obviously, the faster you're going, the more likely there is to be greater damage.